What happens if a meteor strikes you in space? What if you're floating in the vast emptiness of space? No sound, no air, just the quiet hum of your own breathing inside the suit. Earth is a glowing marble far below. Stars glitter endlessly above. Everything feels calm until something catches your eye. It's small, barely bigger than a pebble, but it's moving toward you at 40,000 miles per hour. In the vacuum of space, there's no warning, no sound, no heat, just impact. What happens next depends entirely on the size of that rock. A grain of sand, a baseball, a car-sized boulder. Each one turns this peaceful scene into something very different. So the question is simple, but terrifying. What if a meteorite struck you in space? And the answer isn't what you think. Before we find out what happens, let's step back. What exactly are these deadly space bullets? Meteorites are fragments of rock or metal that break off from comets, asteroids, or even planets. They range from grains of dust you could balance on your fingertip to colossal boulders bigger than skyscrapers. And they're constantly moving, orbiting the sun just like Earth does. Most never come close to us, but space is littered with them. Every single day, millions of tiny meteoroids slam into Earth's atmosphere. Luckily, almost all of them burn up before they ever reach the ground. That's what gives us shooting stars. Now imagine that same process, without the protection of an atmosphere. No burning, no friction, no fireball, just raw rock, traveling faster than a bullet. NASA estimates that even the smallest particles in orbit can reach speeds over 25,000 miles per hour. To put that in perspective, a grain of sand traveling that fast has the force of a gunshot. So if you're floating out there in nothing but your suit, the only thing standing between you and disaster is luck. Here's the thing most people don't realize. Even the smallest meteorites are deadly in space. A grain of sand drifting toward you at orbital speed doesn't look like much. But at 25,000 miles per hour, that speck has the impact energy of a bullet. Now imagine it hitting your suit. The first fraction of a second, you wouldn't even know it's coming. No sound, no warning. Then, puncture. The tiny rock slices through your protective layers like they're paper. Your suit, designed to keep you alive in a perfect bubble of pressure, is now leaking. Oxygen starts rushing out. At first, it's just a hiss, but within seconds, the pressure loss can knock you unconscious. If you're lucky, Mission Control notices and pulls you back inside quickly. If not, your body would begin to swell, moisture boiling off in the vacuum. Now, scale that up just slightly, to a pebble the size of a marble. At that speed, in space, the tiniest fragments are often the most terrifying, because they're invisible until it's far too late. But what if the meteorite isn't tiny? What if it's the size of a baseball, or bigger? Here, survival isn't even a question. At those sizes, you're not dealing with a puncture anymore. You're dealing with pure, unstoppable destruction. Picture a rock the size of your fist slamming into you at 40,000 miles per hour. The kinetic energy is thousands of times greater than a speeding bullet. There's no slow leak, no chance to patch a hole. The impact would crush bone, rupture organs, and tear through your suit in less than a heartbeat. Now scale that up to something the size of a basketball. At that point, it's not just your body that's obliterated, it's everything around you. The force of the collision would send shrapnel flying, turning pieces of your suit and even fragments of your body into secondary projectiles. Any nearby astronaut could be in danger. Scientists estimate that a basketball-sized meteorite carries the explosive energy of a small hand grenade. And remember, there's no air resistance to slow it down. Nothing stands between you and that rock. So while the tiny ones can kill silently, the medium ones end the story instantly. No rescue, no warning, just impact, and then nothing.
Now let's leave the small stuff behind and imagine something massive. Not a pebble, not a basketball, but a meteorite the size of a car, barreling straight through space. At that scale, this isn't about one astronaut anymore. It's about everything nearby.
A car-sized rock traveling at orbital speed carries the energy of a missile strike. If it collides with you directly, you wouldn't even register what happened. You'd be vaporized in an instant. But the real nightmare begins afterward. The impact would send out a spray of debris, shards of your suit, fragments of metal and pulverized rock. each one moving at thousands of miles per hour. Suddenly, space becomes a lethal minefield. Any nearby spacecraft or astronaut could be shredded in seconds. Now imagine this happening near a space station or a future colony. One strike like that could tear through multiple modules, depressurizing entire sections. A single impact could kill dozens, maybe hundreds of people, not to mention ending the mission entirely. And here's the most chilling part: chain reactions. That debris doesn't stop moving. It keeps orbiting Earth, turning into thousands of uncontrolled projectiles. Scientists call this a Kessler syndrome scenario, where one collision creates a chain of new ones until space itself becomes impassable. This isn't just about you anymore. It's about entire missions ending in seconds. After all this, the obvious question is, could you survive a meteorite strike in space? For the tiny ones, maybe. Spacecraft and spacesuits are designed with layers of protection. NASA uses something called a Whipple shield, thin layers of metal that cause small meteoroids to shatter before they hit the main wall. The International Space Station has these shields, and they've saved it from countless micrometeorite strikes. Astronauts also rely on monitoring systems. Radar and telescopes constantly track the bigger objects, giving space agencies time to move satellites or even the ISS out of harm's way. For the smallest fragments, engineers build redundancy into suits and systems to give astronauts a fighting chance. But here's the truth. Against anything larger than a pebble, survival is unlikely. No suit can withstand a rock traveling faster than a bullet. No shield can absorb the energy of a car-sized meteorite. In those cases, the only defense is distance, making sure you're never in the wrong place at the wrong time. So yes, we have protections. Yes, technology buys us time, but in the end, against bigger ones, nothing could save you. Here's the truth. As terrifying as all of this sounds, you'll be glad to know the chances of a meteorite actually slamming into an astronaut are almost zero. Space is unimaginably vast, and even though Earth's atmosphere burns up millions of tiny meteors every single day, the emptiness out there means they almost never collide with something as small as a human body. NASA tracks larger space rocks, and space agencies constantly calculate orbital paths to avoid debris and hazards. So while it's scientifically fun and a little horrifying to imagine yourself getting hit by a cosmic bullet, the reality is you're far more likely to trip in your living room than to be struck by a meteorite in orbit. This nightmare scenario belongs mostly to the realm of imagination, where the what if is scarier than the truth. So, from dust-sized particles that could silently tear a hole in your suit, to car-sized monsters that could erase entire missions in an instant, we've traveled across the terrifying spectrum of what a meteorite strike could do in space. Thankfully, you'll probably never have to worry about it. But isn't it fascinating to imagine? Now, here's a question for you. What do you think would happen if a meteor slammed straight into the International Space Station? Drop your thoughts below. I'd love to read them. And if you want more impossible but mind-bending scenarios like this one, make sure to subscribe so you don't miss the next cosmic what if.